This is Keith Townsend from VirtualizedGeek.com with episode 40 of Virtualized Geeks Tech Talk. So we're going to talk about software-defined data center and expand the conversation on my recent post that talked about software-defined data center as being vaporware. So the ideal of taking a data center and completely virtualizing it and then abstracting it and then being able to manage that virtualized data center via a single pane of glass is kind of what I'm calling vaporware. The concept of software defined in general isn't vaporware, but we're going to spend some time talking about why software defined is important and why we should strive to a software defined data center. And we're going to kind of get away from, for the purpose of this discussion, we're going to get away from the concept or the term software defined data center and focus more on abstraction. So brief history of what is abstraction and what it has to do with computer science in the data center in general. So basically, back in the day of early desktop operating systems and computing in general, we had very low-level protocols or routines for accessing things such as memory, disk drives, so on and so forth. If you're an application programmer, you had to write low-level device drivers for interacting with hardware, including memory, CPU, and disk. All the operating system or modern day operating system virtualized all of that all of those physical components for the programmer so they could just write to that abstracted layer. So instead of having to know what manufacturer a video card was, they could just write to an abstracted layer generic video commands, and that code can now be portable from system to system. This allows a couple of things. One, obviously, it allows programmers to write applications for several platforms, but it also allows for the creation of extremely complex systems. So whenever we abstract something, it has two basic benefits. One, it makes interacting with that system simpler, and as a result of the simplicity, it makes it more scalable. So if we wanted to take, say, our data center and abstract the compute, it would allow us to do things such as move workloads from one physical server to another physical server without knowing any of the physical details of the underlying hardware, or allows us to pool resources and run workloads across several different physical servers, again, without knowing the physical details of the underlying compute. Sounds pretty familiar because that's called virtualization. So the IT infrastructure has matured in one specific area of abstraction, and that's for x86 compute. So when we've abstracted compute, now we have the capability to do a lot more from an operations perspective than we could when we were tied to applications one-to-one to physical hardware components. Now that we've abstracted the x86 hardware that sits atop or underneath the virtualization stack, we can do cool things like hot move workloads from one physical server to another. We can automatically, VMware term, use DRS to automatically load balance workloads across physical platforms. We can move it from one data center to another. And then we even have this concept of running traditional applications that weren't designed for the cloud in the cloud. So this gets us to kind of abstraction, or what VMware and other providers like to call software defined. So we've software defined the physical x86 stack. Now, for the rest of the data center, compute, in networking, we're now looking to abstract those components, and we'll get similar operational benefit from that. VMware likes to call their overlay approach, their NSX product, the next logical step in abstraction, where you create a virtual network that sits on top of your physical network via the NSX hypervisor, and gives you the capability to move networks from one physical network to another physical network, or pause, rewind, and play configurations, just like we're able to do for taking snapshots in the virtualized network. That's one approach to abstracting the network. And then for storage, we have similar applications. So VMware has their vSAN solution, which is kind of their software-defined approach or abstracted approach to storage. But the most important part why we want this abstraction is because it allows two things. It allows, one, portability, and then two, scalability. So you might take a look at the current state of systems. We have networking, which, by all intents and purposes is extremely scalable. I would have to argue that it's extremely complex right now, and we've worked around that complexity with expanding the protocols, and still, so we've taken, if we were to compare it to programming, we've just powered through and just wrote bigger programs, put the intelligence on silicon, and allow the ASICs to basically muscle through. We've solved the problem with muscle and extending existing protocols. Ultimately, that's not scalable. I argue it's not scalable. It limits our ability to create applications that take advantage of the network. So the network itself may be scalable, but applications that we build upon the network aren't as efficient or scalable as they could be if we abstracted the physical network. The same can be said for storage. Obviously, there's providers such as Google, Facebook, Microsoft that has petabytes on top of petabytes. Probably these guys have several. I would have to venture Google's to the point where they have several thousand petabytes of data, of consumer data right now, and so storage in itself is scalable, but they've approached the problem via abstraction. So the enterprise can most definitely, even though the enterprise may not use that scale, the enterprise can start to build applications that's aware of the abstraction, that's programmed for the abstraction layer. And now you can create much more scalable enterprise solutions. And the second thing, portable solutions. At the Software-Defined Data Center Symposium that's hosted by the fine folks over at Tech Field Day, one of the speakers talked about abstracting operations to the point where a enterprise customer can take their data center and move it from one provider to another, because they didn't program for the cloud provider on a low level. So from cloud provider to cloud provider, there's value add that they add on top of their solutions, even within like the OpenStack realm. We have Rackspace, and we have, let's take a couple of providers. We have Rackspace, and we have HP. Rackspace wants to provide database as a service, so you write applications designed for Rackspace database as a service solution. HP has a different implementation of that, so you write towards their API. At the end of the day, if you want to move from one provider to another provider, that creates the complexity that you have to now rewrite your application for the API of the second provider. If you wrote at a higher level, at an abstracted level, and didn't take advantage of the low-level capability of the cloud provider, and just wrote for a common layer, which has a cost to it, I don't know, depends on the application. It could be performance, or it could be ultimately capability. But if portability and scale is important to you, then now you can take that application, run it across multiple cloud providers, which allows scale, or simply don't like the relationship with my applications provider, I can take my operations, not just my application, but my whole IT operations, because it's written to, the whole operations is written to an abstracted model that I can take from provider to provider, no matter if it's MSP, traditional hosted provider, or if it's a cloud provider. Just as long as the cloud provider guarantees a certain level of capability, a la OpenStack, then I can take my application or operations and move it from provider to provider. So this is the dream of software-defined data center. We're not there for most IT operations. For most IT operations, we still have to support legacy systems that either run on RISC-based processors, Itanium solutions, HP UX, whatever. A lot of us still have mainframe. So to say that we can abstract our data center today and move to a completely abstracted model tomorrow is a little bit ambitious. Of course, all those applications need to be rewritten or interface to those applications or solutions, whether it's going to a managed service provider. They'll take your mainframe application, provide an abstraction layer on top of that, and then you can leverage that solution to be able to abstract the rest of your operations. Maybe that's the solution. But overall, the dream of a completely abstracted data center for most enterprises is a bit of a fairy tale. We'll get there eventually, but again, is it there today? No. So that's it for this episode of Virtualized Geeks Tech Talk. We'll catch you at a future date, future fun technology once I think of one. Thanks, and like the video. Visit us at virtualizedgeek.com.